This is the video lesson for Mod 3 Lesson 6, Features of Odd and Even Degrees. The goal of this lesson is looking at features of odd and even degree polynomials. So how can we use the degree of a polynomial to graph? We're going to start with a basic one, which one that we're already familiar with, which is a linear function. A linear is technically considered a polynomial with a degree of 1. We're used to it being in slope-intercept form, or mx plus b. But a lot of the characteristics we're going to talk about actually are ones that we already know about a linear function. So if I don't see an exponent, I know it's a degree of 1. 1 is an odd number, so this is an odd degree. The leading coefficient would be a 2. And it's positive, so that's going to kind of come into play when we graph. This example has one x-intercept, which is at -3, 0. So 1 degree has 1 root, following our same pattern. And then our y-intercept is actually at 0, 6, which we're used to mx plus b. But also we're going to find that when the polynomials have more degree, a larger degree, that constant at the end is going to be your y-intercept. For end behavior, as I go to the left, you can see it's going downward to -infinity. And when I go to the right, it's going upwards to +infinity. When we have an odd degree, we're going to find that the end behavior is always going to go in opposite directions. So one's going to go into -infinity and the other one will go to +infinity. The second function we're going to look at is a quadratic, which we spent a lot of time in Math 2. All of semester 1 of Math 2 is on quadratics. So a quadratic, I have it written here in factored and standard form, and both forms are going to be helpful for different characteristics. First of all, for a quadratic, if the degree is going to be a degree 2, so again, when it's in standard form, we can see the degree pretty easy. That's an odd number or even number, so it's an even degree. Our leading coefficient is a 1, which is a +1. And when we talk about roots or x-intercepts, this example has 2 different roots or x-intercepts. So we see it at -1, 0, and 4, 0. So 2 degrees, and there's 2 real roots. For the y-intercept, let me backtrack just a moment. If we couldn't read it from the graph, remember factored form is real nice because we can tell the x-intercepts right from the factors, like you remember from last year. So if this is a +1, if I take the opposite sign, I could have read it right from the factored form if I couldn't read it from the graph, right? So just keep that in mind. That factored form is nice for finding the x-intercepts. For the y-intercept, I could read it off the graph, but also when it's in standard form, and you might remember this from last year, the constant term is always your y-intercept when it's in standard form. So I could read it from the graph, or if I don't have a graph, I actually know it's 0, -4, because when I put 0 in for x, I get -4. For the end behavior, as I go to the left of the vertex, it's going to +infinity. As I go to the right, it's also going to +infinity. And so you're going to find that for even, the end behavior goes in the same direction, right? So it's either going to both go to +infinity or both go to -infinity. So even functions, you're going to find they're going to go in the same direction, whereas odd degrees, I shouldn't say functions, odd degrees are going to go in opposite directions. The next example we're going to see here is a cubic. So that's when it's to the 3rd degree, right? So I have here again the factored form and the standard form. So the degree for this, you could see the largest exponent is a 3. And a degree 3 is typically going to look like this graph where it kind of makes like this zigzag shape. 3 is an odd number, so that's an odd degree. My leading coefficient is a +1. The number of roots, if I wanted to take it from the equation, if it's in factored form, it's the same as the opposite for each of these. If there was no parenthesis and it was just an x, then it would have been 0. So I actually have, or I could read it from my graph. I have those 3 roots. You could have read it off there and you'll get the same thing. My y-intercept, I could read from the graph, but again, if it's in standard form, the c value, and you can see it's the same on the graph too, is your y-intercept. And then for the end behavior, as I go to the left, it goes to negative infinity. As I go to the right, it goes to positive infinity. And so it's an odd degree, which makes sense that these go in opposite directions, right? So I have one that goes to negative infinity and one that goes to positive infinity. The last one we're going to look at is a quartic, which is degree 4. But we're going to find as we get high, if you were to go higher in degrees, it kind of follows these same patterns. So a quartic, which is degree 4, notice it kind of looks like a quadratic, just a little more going on in the middle. But it kind of follows some of those same themes with the end behavior, where it's going to go in the same direction because it's an even degree, right? So there's going to be more roots involved, but it kind of looks like almost like a smooshed version of a quadratic. So it's a degree 4, which is even. The leading coefficient is a 1, positive. So notice it's a positive. It's going in that normal form we're used to. We're going to see if it's a negative leading coefficient, why that might look different. The roots I can read off the graph, or if I see, look at here, I know it's going to be the opposite of what's in these parentheses. So I have a degree 4 and I have 4 intercepts. My y-intercept, and again, and before I go to the y-intercept, again, you can read those degree intercepts off the graph if you wanted to as well. My y-intercept is in standard form. That's my c value or my constant. So I had -6, but you also see it on the graph. And then you can see from the quartic, the end behavior is similar to a quadratic. So both the arrows are going up. That has to also do with a positive leading coefficient, right? So it's kind of like what we're used to seeing. And the end behavior goes in the same direction because it's even. For the negative leading coefficients, we might see, so all the ones we just saw were positive. This example is a cubic, right? So we just saw a cubic look something like this, if I was to graph it. When it's a negative leading coefficient, notice it's flipped in the other direction, right? Not what we saw when it was positive. So we're going to see that, kind of the same thing as before. The roots, we would still do the same thing. It's a degree 3. We have 3 roots. I could read them from the graph, or I could read them from here. And they're the opposite of what's in the parentheses. But also, the degree would be 3. My leading coefficient in this case is a -1 because it's a negative in front. And the end behavior is still going to go in opposite directions because it's negative. But as I go to the left, it's going up. As I go to the right, it's going down. So it just is, we flipped the order, how we write the end behavior, right? Because we're used to it going to negative infinity to positive infinity. But all the other characteristics kind of remain the same. The last one we're going to see is what happens when we have a double root. So again, that's when it doesn't pass through the point, it just touches the point. So this example is a cubic. So we have a degree of 3, leading coefficient of 1, so that's the shape we're used to seeing. What's happening though is we actually have, even though we only see it cross twice, you can see 1, 0 is actually a double root. Right, a little dr for double root. In our equation, we can actually see that when we have it as this 2 out front, that's squared, that tells us that that's going to be a double root. So if we had to sketch this, we would see that if I was to plot it, I wouldn't pass through that point. I would just hit it and bounce in the opposite direction. So a double root, you can read it from a graph, but you could, in the equation, when you see that little 2 out there, that's basically means it's a double root. So I'm going to count it twice, and then it doesn't pass through the point, it just hits the point and goes in the other direction. The end behavior, same deal. It's negative. It's odd, so it goes in opposite directions. So the left, it goes to negative infinity and a positive infinity because it's a positive leading coefficient. And then to summarize, because a lot of important stuff kind of in this video. So the degree of a polynomial determines the number of roots, which we've seen. If the degree is even, the end behavior will go in the same direction. Or if the degree is odd, it goes in opposite directions. The leading coefficient, if it's negative, it changes the direction of the end behavior. And roots are identified in factored form. The C value tells you the y-intercepts, and again, you can identify those double roots from a graph or an equation. If you have any questions, you can sign up for T-Bolt time, get help in the center, or ask questions during class.